One of the challenges with deploying proxies that assist in censorship circumvention is that there needs to be a cooperating entity that operates the proxy. Sometimes that can be challenging, and additionally the proxies themselves can be blocked. Both of these challenges motivated the introduction of a technology called decoy routing. The idea being that rather than relying on a proxy at an internet endpoint to relay censored content, a cooperating router along the end-to-end internet path could intercept traffic and deflect it towards a covert destination, while still making it appear to a sensor along the path that the traffic was actually headed towards an innocuous destination. Here's a picture explaining that in further detail. A client is ultimately attempting to communicate with a covert destination. To do so, it sends traffic that appears to an adversary or a sensor that's destined for some innocuous destination. In fact, the decoy router intercepts the traffic based on some signal or sentinel in the traffic, and instead sends it to a decoy proxy, and then serves the conventional function of a proxy, such as those we've already discussed. A decoy router can sit on any network path and can act as a proxy or forward traffic to a decoy proxy. There are many decoy routing systems that fundamentally behave in the same way. An initial connection might be set up to a decoy destination. Subsequently, the client might signal to a decoy router along the path that traffic should be deflected to a decoy proxy, at which point a decoy router might terminate the connection to the decoy destination and instead deflect traffic to the proxy that ultimately retrieves content from the destination that the client is attempting to communicate with. Meanwhile, to the adversary, the entire conversation looks as though it's happening between the client and the decoy destination. Here is a figure depicting that process in more detail. A client might start a connection as usual, as seen in step 1. Then, in step 2, the client sends a packet that contains a particular signal or sentinel. The decoy router recognizes that and sends that traffic to a decoy proxy, which then resets the connection to the decoy destination, ensuring that no further traffic is sent from the decoy destination to the client. Subsequent traffic is then forwarded to the decoy proxy, which can continue the communication between the client and a covert destination. There are various decoy routing systems that have been developed over the years. The protocol that I just described was invented and introduced first in a system called Curveball, where the sentinel could be in an HTTP cookie or other HTTP field. Subsequent systems in that same year, Telex and Cirripede, expanded on that idea by embedding the sentinel in various other parts of the internet traffic. Further systems expanded on this initial idea, recognizing, for example, that most internet traffic is asymmetric. In other words, the traffic in the forward direction takes a different path than the traffic in the reverse direction. And subsequent systems added other types of resistance to various active adversarial and traffic analysis attacks. Decoy routing is an approach that diverts traffic to a destination via an in-network proxy, such as a router. It works inline, and recent systems have been extended to work well, recognizing that most internet traffic is asymmetric. A significant drawback, of course, is that conventionally these systems have required ISP cooperation or the willingness to deploy a decoy router. In the past, that's been prohibitive because implementing and deploying such a system in hardware in an operational ISP at high speed often proves to be prohibitive. As software routers continue to get faster, however, the prospect of deploying a decoy router in a software middle box that's on path appears to be increasingly feasible. And I predict that in future years, we'll begin to see the deployment of decoy routers as middle boxes.